We're asked to write the given quadratic expression in the form a times the quantity x minus h squared plus k, which means we're going from the form ax squared plus bx plus c to the special form shown here. To do this, we'll follow these 4 steps. Step 1, if a, the coefficient of the degree 2 term, doesn't equal 1, we want to factor a from the x squared and x terms, or the degree 2 and degree 1 terms. Notice in our expression, a is equal to positive 3, which means we want to factor 3 from 3x squared plus 4x, which is a little bit more challenging because notice how 3 is not a factor of 4x, but we can still do it. If we factor out 3, we'd be left with x squared from the first term. Now if we want to factor out 3 from 4x, we just need to divide 4x by 3. Well, 4x divided by 3 would be 4/3 x, which is what we're left with if we factor 3 out of 4x. Notice if we distribute, 3 times 4/3 x does give us 4x. Now we are going to form a perfect square trinomial here, so we'll leave room for a constant which will complete the square, and then we still have minus 9, and then whatever value we add here we'll have to undo. We know it's going to be a positive value, but because of the distribution, by putting a number here, we're really adding 3 times that positive value, which we'll have to undo, so we'll have subtract a constant here. Step 2, we want to form a perfect square trinomial inside the parentheses here. To do this, we want to add b divided by 2 squared, where b would be the coefficient of the degree 1 term, or the coefficient of x. But because b is 4/3 a fraction, instead of dividing by 2 here, we'll be adding 1/2 times b squared, which is equivalent to b divided by 2 squared. So again, b is equal to 4/3, so we want to add 1/2 times 4/3 squared. But notice how we can simplify before multiplying inside the parentheses. There's 1, 2, and 2, and 2 2's and 4. So we're really going to add 2/3 squared, which would be 4/9. So we're going to add 4/9 here, but by adding 4/9 here, we're really adding 3 times 4/9. So 3 times 4/9. Notice how we have a common factor of 3 here. There's 1 3 and 3, and 3 3's and 9. So this product is really 4/3. So by adding 4/9 here, we're really adding 3 times 4/9, which is 4/3, which we have to undo, shown here in step 3. So we'll subtract 4/3 here. And one last thing, because we have to find this difference here, let's write 9 as 9/1. So we just completed step 3. We're on the last step. We want to factor the perfect square trinomial here and also find this difference. So we'll have 3 times, we'll have 2 equal binomial factors because we have a perfect square trinomial. And then to find this difference here, notice how the common denominator is going to be 3. So let's multiply 9/1 by 3/3. So here we have negative 27/3 minus 4/3, which will be negative 31/3. So we'll have minus 31/3. And now to factor this trinomial, we're looking for the factors of 4/9 that add to 4/3, which will always be b divided by 2 and b divided by 2, or the value that we squared to get the 4/9. Notice how that's 2/3. And therefore we'll have x plus 2/3 here, and of course the same here, x plus 2/3. Let's go ahead and check that to make sure. We're saying that 2/3 times 2/3 is 4/9, which is true, and also 2/3 plus 2/3 equals 4/3, so that does check. Remember, when we have a perfect square trinomial, it's always going to factor into the quantity x plus b divided by 2 squared, which is what we have. So to finish this, we now have our quadratic in the form 3 times the quantity x plus 2/3 squared minus 31/3. So notice in this form, a is equal to positive 3. H, because of the subtraction here, would have to be negative 2/3, and k would be negative 31/3. I hope you found this helpful.